Precalculus, first mid 9 weeks, common assessment. And we have 18 problems today. I'm going to review these 18 problems. These 18 problems are really focusing mostly on vocabulary about domain, discontinuities, basic characteristics of functions. First problem, what's the domain of the function fx equals x over x minus 3? So what we're going to do here is we look for what x cannot be, and so it's kind of management by exception. So our denominator, which is x minus 3, cannot equal 0. So if we put x, the denominator x minus 3, and set it not equal to 0, and solve for x, we see that x cannot equal 3. And so this is the exclusion to the domain. This is where the discontinuity to the function is. And so what we're going to have is, on a number line, what would look like is this. At 3, we would have a discontinuity, but everything to the right of that discontinuity and to the left of that discontinuity is going to exist as part of the domain. And so the break occurs at x equals 3, which is given by answer choice B. Next, for the function g of x equals x squared over x times 20x minus 1 times 20x plus 3, what are the exclusions to the domain? Again, we're looking for, as in problem 1, what are the values of x where the function is undefined, and so those would be the exclusions. And so we could take each one of these factors to the expression in the denominator and set each one of these factors equal to 0 or not equal to 0. So we have an exclusion where x equals 0, and that exclusion appears neither in answer choice A nor in answer choice D. So next we have x minus 1 cannot equal 0, so therefore x cannot equal 1, and so that's going to answer choice C. And the last one here, x plus 3 cannot equal 0, so therefore x cannot equal negative 3. Next problem. 3. Which of the following graphs is not that of a function? It should be pretty apparent. We have something called the vertical line test. The vertical line test, if you draw a vertical line, that vertical line, if that vertical line touches the graph of that function more than once, as is the case in answer choice A, that is not a function. Next, 4. Which type of discontinuity will not likely be seen when examining the graph view in a graphing calculator? I say not likely because sometimes I've seen these newer calculators will have a little resolution break where the function does not exist, but that's going to be a hole, and the hole, when you graph this, now this is the drawn graph of what a discontinuity would look like, this little open circle, but what that really looks like in a calculator for what the discontinuity is, if we have something like f of x equals, let's see, I'm going to think of something here. We have x squared plus 8x plus 15, and down here below we have x plus 3 If we graph this in the calculator, just to show you what that looks like. But now see, we have, based on this function, we're going to have a discontinuity that x equals -3. So x cannot equal -3 because that would make the denominator equal to 0. So if we have x squared plus 8x oops, I got two of those somehow. 8x plus 15 over x plus 3. I'm going to zoom 6. Now we know there should be a discontinuity at x equals -3, but we see no break at all. The only place we can see it is if we go to the table view and we go to where x equals -3, we have an error because that's where the function does not exist. So that is answer. That is problem 4. Next, 5. What's the domain of the function f of x equals 2 times quantity, the square root of quantity 4 minus x? So we know that what is in the radical here, 4 minus x, has to be greater than or equal to 0. So we can do this a couple of different ways. I'm going to just leave the x on the left side, subtract 4. So we have negative x. Negative x is greater than or equal to -4. And if we divide or multiply by -1, we're going to have x is less than or equal to -4. So that's going to be, yeah, we can't have parentheses next to the 4. We got to have brackets. So that's wrong. That's wrong. Yeah, so this is going to be, this should be, C should be right. And just be sure, look in the calculator, 2 times 24 minus x. So 2 times square root of quantity 4 minus x. Let's see what that looks like. Graph. It looks like we have 4. Did I say -4? Oh yeah, I had to do this. That's right. That's why you check on the calculator. So the correct answer is B. Yeah, I went and I forgot to make that sign, but I checked myself, as I hope many of you did on your test. Example of checking my work in real time. Do likewise. Do what I did. I feel good about what I did. Which function is increasing for all real numbers? Well, you can graph each of these in a calculator. I'm just going to sketch the wrong answers here. B, if you have, it's going to look like this. f of x equals -x. So that's decreasing for all real numbers. This next one here, 1 over x, is going to be like this, decreasing and decreasing. So that is not right. This next one here, I forget exactly what it looks like, but it's going to look something like this. And so we're going to have, I think to the right, I think it looks like this. So what it is this one here, we have this jump discontinuity, not increasing nor decreasing, but constant, except right at x equals 0. And next, the one that's the right answer, this cube root of x, is going to look like this. And so this will be increasing. The graph of A will be increasing for all real numbers. Next, the graph of f of x is shown below. Which statement about the graph of f of x is true? A, f of x is decreasing on -2 to 3. So here at -2, and we say on means on the interval of. And interval has to do with x values. And so if we say the function is decreasing from where x equals -2 to where x equals 3, I'm sorry. A looks like it could be a right answer, but let's go ahead and make sure and eliminate the other possibilities. F of x, chance choice B, f of x is increasing on -3 to 1. Well, here's -3, and definitely increasing initially, but then decreasing after x equals -2. So not increasing over that whole interval. That's not right. Next choice C, f of x is decreasing on -3 to 8. Well, here's -3. Well, that's immediately increasing. That's wrong. D, f of x is decreasing on 5 to 3. Well, here's 5. That doesn't make any sense at all. A is your correct answer. But always be wary when A is your right answer, because sometimes that's going to be a test writer's trick to get you to go for the first thing. Be always wary of choice A. 8. For the graph function g of x shown below, where is a relative maximum for the function observed? Now, where should be an alert word, and I think I've put this here. Where, what? When you talk about where, unless otherwise specified, you are talking about what kind of thing? You're talking about x values. Sometimes it will say what is the x value where there is a relative maximum. It could get that detailed. But if we look at this, now I think the distracting answer is answer choice A. Remember in the last one I said be wary of answer choice A? This is a very good example, because if you look at y equals A, well, there's that maximum right there. But the real answer is where it occurs is at x equals 4. So understood properly, A and D should be the first eliminated, and C is your correct answer. I really made a great effort to emphasize it this year. I understand that if you were tricked by this, that doesn't make you a bad person, but it's just, maybe it makes, anyway. Watch out for that. We have a lot of, we don't have a huge list of words that we need to memorize like biology or even chemistry, but we have to really understand these words well, and the tests are written based on looking for your nuance and understanding those words. 9. Which of the following functions is a parent function? Well, your parent functions aren't going to have little ancillary things like negative signs, like 2, and so forth like that. So based on that alone, B is your right answer. One thing I did emphasize when we went over parent functions is usually, not all the time, the parent function will contain the point 1, 1. And then if you look at the first one, choice A, negative x, doesn't include 1, 1. If you look at choice C, 2x squared, it is, now x squared would, but 2x squared is going to look something like this. It's going to miss 1, 1, and square root of x over 2 is going to look like this. It's going to go like this and miss that. So this answer choice B is going to go like this, right through 1, 1. And so that's problem 9. 10. A vertical asymptote is what kind of discontinuity? And I had my discontinuities t-shirt and I think I had you take notes on this more than once. So what kind of discontinuity is a vertical asymptote? Actually, the wording is not 100% right. It should be the vertical asymptote is a result of what kind of discontinuity. That would be a better way of saying it. But that's going to be a type of non-removable discontinuity. Cannot be removed by algebra. Because you remember that last one we had this, when I mentioned this f of x. Oh man, this thing is... f of x equals x squared plus 8x plus 15 over x plus 3. Remember that? Well, this is an example of a removable discontinuity because this thing can be algebraically removed by factoring the numerator and the x plus 3 over x plus 3 in the denominator cancel each other. So that is a algebraically removed discontinuity. If we had f of x equals x plus 3 over quantity x plus 5, and we had, instead of in the denominator x plus 3, let's say we had x plus 2, this discontinuity would not be removed, so there would be a non-removable discontinuity at x equals negative 2, because x cannot equal negative 2. So on the bottom, the example of a non-removable discontinuity, and here at the top, an example of removable discontinuity. Next, 11. For the function fx equals x cubed plus 1.5x squared minus 6x, over what interval is the function decreasing? This is intended to be a calculator problem, and there are other ways you can do this without a calculator, but that's really getting into calculus. So let's go to the calculator here, and that function is going to be x cubed plus 1.5x squared plus 1.5x squared, and it's going to be minus 6x. And we'll just graph this function, see what it looks like. So it's asking over what interval, and what interval has to do with the x value. So I wrote this also on the board, interval So interval will be what x value, what value of x, and the value, what the value of the function is when you plug in the output value. So again, going back to our graph, we see this here, and let's go ahead and really zoom in on this. We're at second trace maximum. So we're going to come to the left of that maximum. It says left bound, press enter. Then we'll scroll to the right, press enter twice. So the maximum value of 10 occurs where x equals -2, in this case 2.0001, so 1/millionth off. So we're going to start at -2, and the only place that thing happens, or -2, is going to be. So now the only possible right answer at this point is going to be C, just to verify the other value. We're going to look for this minimum down here, second trace minimum, which is 3. Just scroll over here. And when we're to the left of that minimum, we can press enter, and we can scroll to the right. Once we're to the right, we press enter twice, and we get a minimum value of -3.5 where x equals 1. So definitely answer choice C. Next, 12. Which of the following represents the end behavior for the function f(x) equals 1 over x? We can see there have been quite a few. This character f(x) equals 1 over x has been a pretty well represented player in this test. So here we go. That's what the graph of this looks like. And end behavior is a synonym for horizontal asymptote. Well, the limit as x approaches infinity, as x gets larger and larger, f of x approaches the x-axis. And so our correct answer for this one is D. Next, for the function g of x equals x cubed plus 1.5x squared minus 6x minus 2, what is the relative minimum? So in this case we have the word what instead of where, and also says the relative minimum. And minimums and maximums themselves are always going to be output values or y values. So anyway, let's go ahead and look at the graph of this. Now it so happens that this function is the very same one I entered, except it's going to be -2 at the end of it. So I'm just going to put -2, and then we're going to see what happens. And so we're going to have our minimum down here where this relative minimum is. So second trace minimum, and we had left bound, press enter, and then it says right bound, so we go to the right of that minimum, press enter twice, and the value of that minimum is now it's kind of confusing in that where it is in the calculator it says minimum x equals 1. Well, that's really kind of misleading, because the minimum itself is y equals -5.5, and so this x equals 1 is where this minimum of -5.5 occurs. And so because we have, it's the coordinate pair 1 comma -5.5, and the answer is going to be this output value, so that's answer choice B. 14. Which of the following functions is bounded? Again, we're going into the understanding of our parent functions of precalculus. And in the sine function, we have this thing here. It keeps on going. The function keeps on going. So we have both an upper boundary and a lower boundary. And so when we're bounded both above and below, we just conclude to say just bounded. Okay, next. 15. For the rational function fx equals 5x squared minus 6x plus 7 over 2x squared plus 10x, the equation for its horizontal asymptote is? Well, horizontal asymptote is also the limit as x approaches infinity of f of x. And there are rules for that. One thing we talk about in this class is the rule that called Betsy, where if the bottom equals the top exponent, the value is going to be the coefficients. So y is going to be equal to 5 over 2. And if you don't have that intuition properly yet, you still, having a graphing calculator in hand, don't have too good of an excuse for missing that because of this. Five x squared minus 6x and that's going to be plus 7, and then we have in the denominator 2x squared plus 10x, and so if we graph this function, it's really hard to see what we have. You really can't conclude, but one thing you can do, or different things you can do, is you can go to your table view and you can, as you increase, go toward positive infinity, you can see what value is being approached. But if you're like me, you don't want to spend the rest of your lifetime doing this. So what I recommend instead, if you go to a second window to get the table set, you can go down here to change this auto to ask, and you do that, and now go to the table view. Instead of scrolling, you can put a value in here and see what you're approaching. So you can put a real large number. I'm going to put 1,000,000 in here, see what we get close to. Yeah, 2.5, which is 5 over 2. Okay, now 16, the function h of x equals x over x times 20x minus 1 times 20x plus 3 contains how many discontinuities? I had a student who wrote on the test, I'm not kidding you, what is a discontinuity and a question mark. Well, if you were in my class this year and you don't know what a discontinuity is, you had to be on a different planet. Because if there was one thing I thought that we emphasized beyond all question was this. Now, if you just made a mistake and you graphed it and you counted 2 breaks instead of 3 and put down 2 as an answer, I can understand that. But when you ask what is a discontinuity, I need you to get to class, to be awake, be on the same planet, please. Well, algebraically, if you set each of these factors equal to 0, we know that x cannot equal 0, and if we set x minus 1 cannot equal 0, therefore x cannot equal 1. And then similarly, if you set x plus 3 cannot equal 0, x cannot equal -3. So if you understand that, you just put in 3 and bubble that in, and you're done. Now, again, if you lacked understanding to be able to do that, you can still go to you can go here and put in x over, whoops, I put 1 there, x over x times quantity x minus 1 x plus 3. And when you graph this, I'm going to go back to a table set. I'm going to go start at 0 and go back to auto. And if you graph, we see 2 breaks. And so if you don't catch that, now if you look right here on the y-axis, you'll see a little break with this particular calculator. It knows enough sometimes to make a break. But where you can really see it is when you go to the table view and you see those errors. So I'm just looking at this and I see 3 errors here at these integer values of -3, 0, and 1. So yeah, 3 discontinuities. 17, one that I had quite a few people miss, and let's go ahead and put this in here and figure out how that happened. So the elevation to feed the ball thrown in the air is given by the function f of t equals 6 plus 88t minus 16t squared. So let's go put that in our calculators. Definitely a calculator problem. So 6 plus 88x minus 16x squared. Now the wrong answer that I got most commonly on this one was, I believe they found it like this, because if you go to the table view with the standard setting, you're going to see a maximum value of 126. Now that looks like it's what you see in the table, so that looks like a right answer. But you have to look into more detail, because all this tells you is the value at each one of these integer input values. Now one way to get around that and still use a table is go to that table, delta table, and change that to a decimal like 0.1. So if we do a delta table there, we can, I picked a value, I have to scroll. Let me go back here. I'm going to go to table set of 3 just to get closer to what we're looking for. So here at 3 we see 126, but if we go here to around 2.7, 2.8, we get close to 127. And I venture to say that if we go even tighter view, if we go to second table set and maybe go to 0.01, we can even get a tighter view of this. 2.7. Yeah, so we get even a tighter view here. So right here, 127, we see. So that's a lot of table manipulation. But 127 is going to be our answer. I want to show you also graphing. Going to the graph mode, 127. Yeah, 126 was a very common answer I saw on this. So as a test writer on this one, if you put down 126, I got you on that one. Okay. If we graph this, we don't see hardly anything. We have to change our window view. I'm going to go to window setting, go from 0 to maybe 6, and Y value I'm going to go like 0 to, I don't know how high to go, 150. I don't know if that's going to get us there, but I'll just start out there. Yeah, it's going to work. So you can trace to get to the top of that, but I'm just going to go to second trace maximum, which is 4, and then we have left bound question mark, so I'm going to go over to the left of that vertex. Once I'm to the left, press enter once, then go to the right of the vertex, press enter twice, So at x equals 2.75 seconds, we get a maximum value of 127. The last one, 18, for the equation y equals negative x squared minus 10x minus 18, where is the maximum? So again, when we look at this, we are talking about where, what, right? Where is the maximum? You're talking about x values. So I think this is another common mistake on the test. So negative x squared minus 10x minus 8. We'll make sure I get this right. Negative x squared minus 10, minus 18. That's what it is. So we graph this. I'm going to go to standard window, zoom 6. And we're looking for the x value. Let's find out what that is. Second trace. We're going to get to the maximum 4. We say left bound question mark. So we're going to go to the left bound. Left side of that vertex. We get there. We press enter once. Now we go to the right. Once we get to the right, we press enter twice. So we get a maximum. Now, here's the thing is I had people put down 7 a lot, but where it occurs is at x equals negative 5. So we have the point, coordinate pair negative 5, comma 7. But when we talk about where, we're talking about the x value. So you should get negative 5. Now make sure when you have a situation like this that you put the negative. I saw one person I think who forgot to put a negative sign. But yes, 7 was a very common answer for this. And yeah, there was some justification for that 7. But the right understanding of where what gives you negative 5 as your correct answer. Anyway, that's all I have today on this. I hope this has been helpful to you. I thank you for viewing. Take care.